We started off looking at how do we graph tastes in a two-good world, and then we looked at how do we mathematically represent taste using utility functions, where we said the idea behind a utility function is that for any bundle, it's going to assign it a utility value such that more preferred bundles are assigned a high utility value and bundles that you're indifferent between are assigned the same utility value. Now, so that is what we initially looked at, like over here. That is what we looked at. How do we write the utility function mathematically and all. So now let's look at how do we plot a utility function. Say we have this utility function, ux1, x2 is x1, 1 by 2, x2, 1 by 2. Now we would need three dimensions to plot this utility function because we need one dimension like this to plot x1, one dimension to plot x2, and one dimension to plot the resulting utility value. So we can plot utility functions if we're looking at just a two-good word. So in that case, we would need three dimensions to plot our utility function. And here's something to note over here is this is a utility curve, not an indifference curve. Initially, when we were talking about graphing taste, we were talking about representing them in a two-good world using indifference curves. Now, this what we've plotted over here is a utility function. So this is a utility curve, not an indifference curve, because this is showing us is that for a bundle made up of x1 and x2, for different combinations of x1 and x2, what is the utility we'll get? An indifference curve is something else. An indifference curve for this would have shown all combinations of x1 and x2 that give the same level of utility. This is not what this utility curve is showing us. This is a graphical representation of a utility function. This is showing us that if I take any combination of x1 and x2, what are the resulting utility values for those combinations of x1 and x2? So this is a utility curve, not an indifference curve. So when in a two-good world, we're plotting a utility function, what we get is a utility curve like this, which you can plot in three dimensions. Now how are utility functions and indifference curves related? If we plot x1, x2 is equal to x1, 1 by 2, x2, 1 by 2 in three dimensions like this, we don't get an indifference curve. But now let's look at how are they related to indifference curves, utility functions. Now, utility functions give rise to indifference curves in the 2D space for each level of utility. What this means is that in our utility function, for any given level of utility, we can find an indifference curve corresponding to that utility level. If I fix the utility level over here, then all combinations of x1 and x2 that give me that level of utility will basically give rise to an indifference curve corresponding to the level of utility. So when you want to plot indifference curves using utility function, you have to fix the level of utility. And then you can see for that level of utility, all those combinations of x1 and x2 that give rise to the level of utility are giving rise to an indifference curve corresponding to that utility level. So for instance, if we take this utility function, ux1 x2 is x1 x2, then the equation of the indifference curve corresponding to utility level of k. Say I want to look at the indifference curve which corresponds to utility level of k. So I'll fix the utility ux1 x2 is k, and then from here we can solve for x2 as the function of x1, because when we're plotting the indifference curve on the vertical axis we're taking x2, and on the horizontal axis we're taking x1. So over here, so basically this utility function has given rise to an IC corresponding to utility level k, which has this equation. So basically, essentially the idea is, given the utility function, we can find indifference curves for each level of utility. If I pick a utility level of 1, it's going to show me all the combinations of x1 and x2 which give utility 1. If I choose k to be 2, it's going to give me all combinations of x1 and x2 which give utility level 2, and so on, right? So when we plot the utility function as is like this, if in a two-good world, if we're plotting this utility function in a three-dimensional plane, that's not an indifference curve. That's a utility curve. It's a graphical representation of our utility function. When we're plotting indifference curves from the utility function, then we're fixing the utility at a particular level. Ux1, x2, we're putting it equal to some particular utility level like k. And then we're seeing all combinations of x1 and x2 that give us that utility level. So in that case, that gives us IC. So from utility function, we can get indifference curves by fixing the utility at a particular level to get the indifference curve corresponding to that utility level. Because now, once I fix the utility level at k, this is essentially showing us all combinations of x1 and x2, which give us utility level of k, right? Where ux1, x2 is k, right? Showing us all those combinations. And this is essentially what an indifference curve is. We know an indifference curve shows us all those bundles that we're indifferent between, and each indifference curve corresponds to different utility levels. So in our utility function, once you fix the utility level, then we'll get all the combinations of x1 and x2 corresponding to that utility level. So this essentially gives us the indifference curve corresponding to that utility level.